In this video, we are going to discuss about the next type of amplifier, which is going to be series. In other terms, it is called as current series amplifier. Like the last amplifier, here also we have the same methods, and let us see in detail in step manner. In series feedback amplifier, the first step is going to be the finding out the input resistance, where we are going to draw the equivalent circuit for this particular amplifier. Hence, the input circuit here is represented in Thevenin's equivalent and output circuit as Norton's equivalent circuit. Hence, the input feedback is going to be the source voltage divided by the input current. So the step 1, we have drawn the equivalent circuit for this particular amplifier. Next, going on to the step 2, where we are going to obtain the expression for the source voltage. Hence, it is always mandatory to apply the KVL. So when we apply KVL, here the source voltage is going to be the Vs, and it is going to pass through the current II with respect to Ri. So the equation becomes source voltage, that is Vs minus IIRI minus Vf. So what is the value of Vf here? Yes, it is going to be Vf is equal to beta I naught. So the expression for Vs is going to be as such. Vs is going to be IIRI plus Vf. In other terms, IIRI plus beta I naught. The next step is going to obtain the expression for current in terms of input voltage. So the output current is going to be the product of transconductance with respect to input voltage and the output resistance with respect to the output resistance and as well as to the load resistance. So once we got the I naught, we will proceed with the step 4, where we are going to obtain the expression for the input resistance. So we are now going to substitute the equation 2 in equation 1. So we will get RIF is equal to Vs by II, or the final equation is going to be Ri into 1 plus beta Gm. So now we are going to obtain the output resistance for the feedback amplifier. Step 1, we are going to draw the same equivalent circuit. Now what we are going to do is, at the input source, we are going to short circuit it and make this Vs is going to be as 0. And at the output side, as usual, we have disconnected this particular load resistance. In step 2, we are going to obtain the expression for I in terms of voltage. So we are going to apply KCL, that is Kirchhoff's current law, in the step 2. So for current is going to be the with respect to voltage and the resistance. So the input voltage is given as VI, that is equal to V minus Vf, or otherwise it is going to be minus B I naught. See here we have Vf, which is going to be equal to minus B I naught. And from this we are going to get the second step completed in terms of current for voltage. Now in step 3, we are going to obtain the expression for output resistance. So ROF is going to be V by I. As we know the previous values of V and I, we are going to substitute the same. Hence, from the first amplifier, we know that R dash of OF is going to be ROF parallel to RL. So the final equation for R dash OF is going to be R naught dash into 1 plus beta Gm by 1 plus beta Gm. So beta is always going to be the gain and Gm is going to be your transconductance which is present in the amplifier.